All right, it says children's ages. Mrs. Johnson's children are 2, 2, 3, and 5 years of age. It says calculate the standard deviation of their current ages. Okay, so in order to find our standard deviation, we have a few steps. The first one is find the mean. Okay, and then the next step is to subtract the mean from each number. Then we square the results, add up the squares, then we divide by n minus 1, and we take the square root. And if you want the formula, it's going to be x minus x bar quantity squared summed up divided by n minus 1 taking the square root, and that's going to give us s, the standard deviation. So here, what is our mean? Our mean is going to be adding up all of the numbers divided by how many we have. We do 2 plus 2 plus 3 plus 5, and how many numbers do we have? We have 4. N is equal to 4. So in this case, 2 plus 2 plus 3 plus 5, that adds up to 12. Divided by 4, my mean is 3. That's my x bar. Okay, this is x bar. So I'm going to subtract 3 from each of these numbers. Okay, this gives me -1, -1, 3 minus 3 is 0, and 5 minus 3 is 2. So that was step 2, subtract the mean from each number. Now I'm going to square the results. So each number squared, that's going to give me -1 squared is 1, -1 squared is also 1, 0 squared is 0, and 2 squared is 4. That's squaring the results. Now I'm going to add up the squares. So I'm going to do 1 plus 1 plus 0 plus 4. This gives me a total of 6. I divide by n minus 1. So n is 4, so n minus 1 is equal to 3. So now I'm going to do 6 divided by 3. I get 2. And my last step is to take the square root. So I'm going to take the square root of 2, and that's going to give me 1.414. That's my standard deviation. 1.414 years is the standard deviation. That's part A. Okay. Then part B says, without doing any calculations, indicate whether the standard deviation of the ages in 20 years will be larger or smaller or the same as the standard deviation of their current ages. Then it says check your answer by calculating the standard deviation of the ages in 20 years. And explain how adding 20 to each of the numbers affects it. Okay, so standard deviation is a measure of spread. Okay, so right now we say the amount of spread in these 4 ages, 2, 2, 3, and 5, is 1.414. Okay? In 20 years is the amount of spread between the people's ages. These children are going to be 20 years older, but is the amount of spread going to change? No. They're still going to have the same spread, the same spacing between the age. Okay? So the spread will not change in 20 years. Will not change 20 years from now. And we can confirm this, okay? So in 20 years, the ages will be 22, 22, 23, and 25, okay? If I calculate, and we're going to do the same steps, I do the mean is going to be, I add all of those up, divide by 4. This is going to give me 23 years, and I can just confirm that if you're curious. 22 plus 22 plus 23 plus 25 gives me 92 divided by 4. 92 divided by 4 is indeed 23. I'm going to subtract 23 from each of these numbers, and you'll see that these numbers I get the same, -1, -1, 0, and 2. So when I square these, I'm just going to get 1 plus 1 plus 0 plus 4. which is going to give me 6. 6 divided by 3 is going to give me 2. Square root of 2 is 1.414. So we're going to get the same exact answer that we did before. Now, I guess I had the thing not centered in the camera, but I think you were all able to see the steps. Okay, and it says, find the mean of the children at their current ages. Well, we did that. The mean of the children at the current ages is 3. And it says, without doing any calculations, indicate whether the mean age in 20 years will be larger or smaller. And so we actually already did that, but we know that the average age right now, the kids are really young, 3 years old. But in 20 years, is the average age going to change? Yes, in 20 years, the average age will be 23. Okay? So adding 20 to all of the numbers, and this is important for part B, adding 20 to the numbers did not change the spread or the standard deviation. Change the standard deviation because the spread is unaffected. On the other hand, in part D, it's asking adding 20 changes the center. Okay, so the mean is a measure of center. Adding 20 does change the mean. In fact, it increases the mean by 20 because the center, the average age, is 20. So right now, if you were asked, oh, what's the, about what age are Mrs. Johnson's kids, you'd say, oh, they're about 3 years old. One's a little bit older, and 2 of them are a year younger. And in 20 years, yes, what's the average age of Mrs. Johnson's kids? You're going to say, oh, they're about 23. Okay, so adding a number does change the center, does change the mean, but adding a number does not change the standard deviation because the spread does not change.